Hello everyone! Today I'm going to talk to you about how to use the Desmos graphing calculator to complete the Explore portion of the lesson in Unit 6, Day 23, Graphing the Standard Form, Part 1. The focus question for this lesson is what is important to pay attention to when graphing quadratic functions in standard form. So, what you're going to want to do is you're going to want to go to desmos.com/calculator. This calculator is going to be your #1 resource reference for this lesson. So I'm going to jump ahead to the Explorer to demonstrate this. So the directions say, use the Desmos graphing calculator to graph y equals x squared. Then experiment with each of the following changes to the function. Record your observations and include sketches if helpful. Okay. So the first question says, what would happen basically when we add different constant terms to x squared? What are our observations when we do that? So for example, if I take x squared and I add 5, or I add 10, or I subtract 3. Well, let's use the calculator for us to help us figure that out. First, I'm just going to show you the standard form of a quadratic function. Y equals ax squared plus bx plus c. This is the standard form of a quadratic function. So the first question is saying when we change the constant term, what happens? Well, I'm going to show you. Let's just keep x squared, right? And let me remind you this. This is the parent function. Y equals x squared is the parent original function. There's a 1 in front of the x squared, nothing's being added to it. So we're always asking ourselves, how does this original function change when I do something to modify the parent function? So the first thing is when we change the constant, that's the c. So I'm going to press plus c here. I'm going to add a slider. Sliders are really helpful because they help us actually play around and try a whole bunch of different numbers here. So if I go here, it's like saying I added 5. That's making c 5. So it's x squared plus 5. And then it asks us what happens when I add 10. And then it asks us what happens when we add negative 3. Okay, so you should start to see some things happening. Even notice when you add negative 3, where does what is the minimum of the graph? Where is it intersect? Where is the vertex? When I added 10, where was the vertex? Interesting observation to notice. And I can actually press play. Let me zoom out right here. And I'm going to watch just as I go from negative 10 all the way to negative 10 and back up. What happens to my graph? How does changing the c term affect my graph? That's the big question. Okay? So I'm going to pause that, and you can go ahead and jot that answer down here. And if you need to pause the video, you can. Okay. The next question says, when we multiply x squared by different positive coefficients greater than 1. So I'm going to change this. I'm not worried about the c now. I'm just worried about when I change the a. I'm going to add a slider for a. I'm going to get rid of this c slider. And it said coefficients greater than 1, so I don't even want to see the negative, so I'm going to change this to 0, 10. No, maybe I'll do 20. So now this goes, I clicked here just so you know, press enter, and now I'm at 0 to 20. So what happens when I change the oops, sorry. Actually let me change this to 1 because it said positive. Okay, so what happens when I multiply this by numbers greater than 1? What's happening to my graph? What happens when I change my a term and I multiply it by numbers greater than 1? And if you really wanted to even try, you could be like, well, what happens if I multiply by 500? Right? That gives you even more perspective. Okay? And so you can jot down your observation here about that one. And again, pause the video if you need to. The next question says, what happens when I multiply x squared by different negative coefficients less than negative 1? Okay. So it said, and this is important to notice, it says negative coefficients less than negative 1. So I'm going to change my slider now. I'm going to say I want it to be from negative 1 to negative 20. Interesting. What happened first just overall, what happens when I multiplied by a negative, right? When I took that A and I changed it to a negative, what happened to the graph? And you know what, let's have this start at 1. Right, here's my original parent function. What happened over here? And then as I get more and more negative, as I get further away from 0, what happens to the graph? This one has a little bit more observations to notice, right? You want to notice what happens when I multiply by a negative and what happens as I get more negative, as I get to numbers further away from 0. And you can even watch this. I'm going to change this to -1. And you can kind of just watch what happens between -1 and -20. And also notice what happened to the graph overall. And you can jot that down right here. And the last question says, what happens to the graph when I multiply x squared by different coefficients between -1 and 1? So let's change this. I'm still worried about this coefficient. I'm going to do -1 to 1. And I'm going to press play. So notice first the difference between when I'm in the negatives to when I get to the positives. And I want you to also notice what happens to the graph. Maybe it will help if we look let's just look between 0 and 1 first. When I'm at 1, here's my graph. What happens as I get closer to 0 to my graph? What happens when I multiply by decimals less than 1, fractions less than 1? When I multiply by, let's do 1/2. So here's 1/2, here's the original, here's 1/2. What happened to my graph? What about 0.25? What happened to my graph? So when I'm multiplying by numbers between 0 and 1, or let's do between -1 and 0, right, here's -1. What's happening to my graph as I multiply by those fractional values? That's something really important to notice. We already know that when it's what happened in the previous slides, right? Positive, how it changes versus negative. But what's happening when we multiply by fractional values? And how is that different from when we multiplied by by numbers greater than, fractional values between 0 and 1? And how is that different, or between 0 and -1? And how is that different from multiplying by numbers greater than 1 or less than -1? How is that different? What's happening here? Let's watch it. So as we get closer to -1, it looks like it's getting skinnier, and then it's getting much and much more wider. Okay, great. And so now you can take a moment and you can jot down those observations here. Okay, and so the main questions of today, or the main goal of today, is I want to know, or your job today is to identify what happens with y equals ax squared plus bx plus c, right? We didn't talk about the bx. There's one thing to notice about what happens when we change the constant. Okay, what happens to the graph here? And then there's one thing we should have noticed, there's multiple things we should have noticed about what happens when we change that coefficient. We want to know what happens when it's negative versus positive. I want to know what happens when it's greater than 1 or less than -1. And I also want to know what happens when it's between 1 and -1. When it's a fractional value less than 1 or greater than -1. Right, so it's between those. It's like those 1/2, those -1/2. What's happening to the graph? And that's what your observations here are going to state. And so when you come back together as a class, you should then be able to jump in and discuss, the summary What is important to pay attention to when graphing quadratic functions in standard form? Okay, so thank you for engaging in this video with me. I hope the slider feature is a resource you can continue to use to analyze and study functional relationships.